didn't just dry up, it stopped working. A planet doesn't have to die for that to happen. It just has to lose the systems that hold it together. Mars is the clearest example that we have. Everyone knows the Mars we see now. Cold, red, thin air, dust everywhere. A planet that looks like it was never built to hold anything alive. But that may be the wrong story. Mars may not always have been uninhabitable. Its surface still carries the marks of rivers, lakes, floods, and weather systems that should not exist on the planet we know today. The evidence is not subtle, it is carved into the ground. One of the clearest clues come from ESA's Mars Express mission. Its images of Shalbatana Vallis show a channel near the Martian equator, stretching for about 1,300 kilometers. This is not a small crack, it was a scar cut by floodwaters, likely when huge amounts of groundwater burst onto the surface billions of years ago and rushed downhill with enough force to carve a valley into rock. That scar is not the story, it is the warning. A channel like that asks a harder question. What kind of Mars could move that much water? What kind of atmosphere could let liquid water matter at the surface even temporarily? What kind of climate could allow rivers, lakes, and flood systems to shape the planet before everything collapsed? The Mars we see now cannot do that. So, something changed. And the evidence of that change is not hidden in lab data. It is written across the planet's surface in channels, craters, and mineral deposits that only form when liquid water is present. The clues came from different places, but they kept pointing in the same direction. In Gale Crater, curiosity found evidence of ancient lake environments, where water once gathered long enough to leave layers behind. In Jezero Crater, Perseverance found the remains of an ancient river delta, where flowing water once carried sediment into a lake. From orbit, Mars Express has mapped valleys and outflow channels that show water did not just appear in small patches. It moved across the planet with force. Some researchers have argued that Mars may once have had large bodies of water, possibly even an ocean in its northern lowlands. None of this means that Mars was Earth, it means Mars was not always this. The planet did not begin as the clean, dry corpse that we see in images now. It had moving water, it had sediment, it had environments that could preserve clues for billions of years. It may have had conditions that stayed stable long enough for rivers to build deltas and lakes to leave minerals behind. Then the stability failed. Not in one explosion, not in one clean disaster. Mars did not wake up one day and become dead. The systems that helped it hold on to better conditions weakened over time. The most important failure may have started deep inside the planet. Early Mars likely had a global magnetic field, active for roughly the first 500 to 800 million years of the planet's history. The field would have acted like a shield, helping protect the atmosphere from the constant pressure of the sun. But Mars is smaller than Earth. Its interior cooled faster, its magnetic dynamo faded, the shield weakened. Once that happened, the atmosphere was more exposed. Solar wind and radiation had more access to the upper atmosphere. NASA's MAVEN mission measured the escape rate directly for more than a decade. It found the solar wind strips away roughly 100 grams of Martian atmosphere every second, with that rate jumping far higher during solar storms. Over the full history of the planet, that accumulates. The early sun was more active and the escape rates were considerably higher. What MAVEN measured was the slow end of a process that started when the magnetic shield failed. Air leaves, pressure drops, temperature becomes harder to regulate, surface water becomes harder to keep stable. A lake does not vanish because the water itself fails. It vanishes because the environment around it can no longer protect it. Liquid water needs pressure. It needs temperatures that do not swing too far for too long. It needs an atmosphere thick enough to keep it from boiling, freezing, or escaping into the air and then into space. Mars began losing those conditions. The water was the visible symptom. The failure was bigger. Mars didn't simply lose water. The environment stopped functioning the way it once had. That is why the old riverbeds matter. They are not just signs that Mars was wetter, they are evidence that the planet once had systems capable of supporting surface change on a massive scale. Rivers do not carve channels alone. Floods do not reshape valleys without pressure. Temperature, gravity, ice, groundwater, and atmosphere all interacting in the right way. When one system weakens, the others become harder to maintain. A thinner atmosphere makes the surface colder and less protected. More radiation reaches the ground. Water exposed at the surface becomes unstable. Ice can remain, but open water becomes harder to sustain. Weather changes, erosion changes, chemistry changes. The planet stops behaving like a place that can keep its own conditions steady. Mars may not have lost one thing. It may have lost the ability to keep everything else stable. That is the real collapse. The ancient flood scar becomes more than a dramatic image. Shalbatana Vallis is a mark left by a Mars that no longer exists. Gale craters, lakebeds are not just old deposits. They are records of a planet with enough environmental order for water to gather, sit, move, and leave layers behind. Jezero's delta is not only a target for samples, it is proof that a river once delivered sediment into a lake on a world that now cannot keep liquid water waiting at the surface. Every clue points backward to a version of Mars that worked better than this one. Every clue also points to what failed. The magnetic shield faded, the atmosphere thinned, the surface became more exposed, temperatures became more hostile, stable water retreated. Habitability, if it ever existed, became harder and harder to maintain. This is not a simple domino chain. Planets are messier than that. Mars changed through linked systems across more than 3 billion years ago. The planet was not defeated by one missing ingredient, it was weakened by the loss of stability itself. If you want to understand what quietly decides whether a planet keeps working, not the surface story about the systems underneath it, subscribe to SpaceWatch. The collapse did not end when Mars went cold. MAVEN measured the escape rate for more than a decade before the mission ended. Its data showed that atmospheric escape is not only ancient history, it is still happening today. What MAVEN detected was a slow remnant of a much faster process, one that ran harder when the young sun was more active and Mars no longer had a global magnetic shield. The isotope record confirms it. Measurements of Martian atmospheric water show a heavy hydrogen enrichment roughly 5 to 6 times. Earth's ocean value. Curiosity also found ancient Martian clays already enriched with deuterium, which means the loss began early and kept running. The lighter hydrogen escaped. It left the planet. The water that Mars once had did not simply evaporate, it was lost to space, molecule by molecule. The scar in Shalbatana Vallis is 1,300 kilometers long. It was cut by water moving across a planet that no longer exists in that form. The planet that produced the flood is not the planet in our images. Whatever held it together long enough to carve that channel did not hold. The conditions that made a 1,300-kilometer flood possible are now gone. What remains is the record they left behind. Mars may have once worked. Then it stopped being able to stay that way. Not because of one catastrophic event, because the quiet systems that held it together stopped holding. Before humans try living on Mars, they may first need to understand why it stopped working. If Mars's magnetic dynamo had lasted another billion years, would the planet's surface today look meaningfully different? Or was the atmospheric loss already too far along to change the outcome?